Alrighty, study guide problem number 2. We're told dp over dt, which is just a fancy way of saying the derivative, is equal to some constant k times the square root of t, which stands for time, is the rate of growth of a population of bacteria at time t, where k is a constant, like we said. And we're told that the initial size of the population is 200. Again, that's a fancy way of saying p of 0 equals 200. And after 10 days, so p10 equals 500 is the size of the population at that time. And it wants us to find p of 5, estimate the population after 5 days. So in order to do this problem, you guessed it, we're going to need to integrate. So if we integrate this function, so if I integrate, and that's a really bad integral symbol, sorry, it's hard on this drawing pad. There, it's not, I just am out of practice. But anyways, that's an integral symbol for our sakes, and we want to integrate k times the square root of t dt with respect to t is the variable we want to integrate. So if we do that, we're going to get k. It's going to stay the same, but then when you integrate the square root of t, remember that's the same as t to the 1/2, so raise the power and you get t to the 3/2. Divide by that, dividing by 3/2, it's like multiplying by 2 over 3, so we got 2/3 k times t to the 3/2 plus c, our constant of integration. And again, this is our, we integrated and we got our population function. So now, since we know that the population at time t equals 0 is 200, we actually don't even need to do any work to find our constant of integration, because if you were to substitute 0 into this, you'd substitute 0 in for t and it would make everything go away except for c, and you would get p of 0. I'm sorry, not p of 0. Boop, boop, boop. Oh, it's not letting me do it. P, okay, sorry. If you do that, then you would get 200 equals c, our constant of integration. So then we have the function p of t equals 2/3 k, sorry, that's not a minus, let's say times t to the 3/2 plus 200. Alright, so we found our function. We're off to a good start. Now we just got to figure out what k is. So in order to do that, we can take this value and plug it into our equation. So p of 10 is 500 equals 2/3 k times t to the 3/2. And just kidding, because t in this case is 10. So we want to take 10 to the 3/2 and then plus 200. Now at this stage it's just algebra. Solve for k and then you got your k value. So if you go ahead and subtract 200 from both sides, so you got 500 minus 200 divided by, we're going to divide by 2, we're going to multiply by 3 from that 2/3 right there, and then we're also going to divide by that 10 to the 3/2. Plug that into your calculator and you will get your k value, which is, we're going to say approximately, those are really bad approximately symbols, approximately 14.2302. So again, the whole point of that is now we can write our function p of t equals, where is it, 2/3 k, which is 14.2302, throw that in parentheses, times t, I don't know why I put that in parentheses, doesn't matter though, t to the 3/2 plus 200. Now we want to use that to evaluate for the t value of 5, and again, just plug it all in, 2/3, 14.2302 times 5 to the 3/2 plus 200. Simplify it all and you will get p of 5 equals 306.066. And that, my friends, is your final answer. So, I'm sorry, it's been taking me a while to end these videos. Done!